Right.
You mentioned vegans earlier on. Is there, I mean, obviously a vegan person will have difficulties in getting EPA and DHA, but where would you expect an omega-3 index for these people? If you're strictly vegan, is that a problem?
Well, I mean, we did one study with vegans and found about 3.7.
3.7
was what the average was. Yeah, and there hasn't been that much work done with vegans. And yeah, I do think that there's probably a problem. I mean, vegans have an entire lifestyle that's pretty cardiovascular friendly. So their risk for, I mean, there's a lot of factors, obviously, but I would be more concerned about the brain effects, the long-term brain effects of having that low in omega-3.
Yeah, yeah.
Not so much the heart, probably, for a vegan, because they're eating, you know, pretty fit people typically.
Right. I mean, the rest of the diet is actually very cardioprotective, and many of them also have a very healthy lifestyle as such, right? So
but typically aren't vegans and smokers.
Compensates that. Yeah.
Yeah.
Sure.
So,
and this is just a thought, right? But if you would imagine that people would take over several generations, no EPA or DHA, would that have it must have in some way an effect on the brain size? Or,
it would have to. There's still a live question as to whether you can get enough DHA from ALA for the brain. That's certainly not a settled question at this point. And it would be, you know, well, it depends on the rest of the diet, you know, how much conversion you might get. You know, folks like Bill Lanz would say if you have low enough omega-6 intake, linoleic acid intake, then you'd get more conversion. And that may be true. But that also presumes that having a low omega-6 is doesn't have other bad consequences. And we've seen studies where, similar to the one we just published in Nature, where people who have higher omega-6 levels, again, in multi-cohorts followed for many years, those who have the highest omega-6 levels have the lowest risk for cardiovascular disease and the lowest risk for diabetes. And so we think that, you know, we can't, just because we love omega-3s doesn't mean we have to hate omega-6.
Yeah, true.
And I think there's a lot to be said for the importance of linoleic acid in the diet. So I'm a fan of omega-3s and of omega-6s.
Right. Okay, now going back to the omega-3s then, if you look at the EPA, DPA, and DHA, do you have a favorite one? So where you'd say, all right, look, I think this one is more important than the other one? Or
no, I really don't. I mean, there are obviously certain tissues. DHA is much more incorporated in the membranes than EPA is, and that may have a structural effect. That may be, and I'm sure it's for a reason. Nothing happens without a reason. In the way the body is built. But we know EPA gives rise to important anti-inflammatory metabolites. So does DPA, and so does DHA. They all come together in the package of fish. So to me, I don't favor using one over the other, despite the results of the REDUCE-IT study, which just used EPA. That doesn't mean to me that DHA doesn't work by any means.
No, I fully agree. And I think it's a lot, you know, quite often in these things, it's also a marketing story about
Totally. Oh yeah, totally.
I absolutely agree. We need, well, who am I to say, but I think we need both of them, right? All three of them, basically. Right?
Yeah, I mean, I think we don't need to eat DPA. We make it.
Right.
From EPA.
Exactly.
I was struck when I compared the levels in the blood of EPA, DPA, and DHA in the US and Japan. So not surprisingly, in Japan, EPA and DHA levels are much higher than they are in the US. DPA levels are the same.
Oh, that's
in Japan and US.
Really?
Yeah, I was shocked actually by that. So we know there's not that much DPA in food. So even in seafoods, there's more than just in steak, of course, but the body seems to want to have a certain amount of DPA, and it doesn't seem to make much difference how much EPA and DHA you eat, at least in that particular comparison. So that's another reason why DPA is not in the omega-3 index. It really is not responding the same way to diet as the other two do.
No, I find that very, very interesting because many years back, we also had a company approaching us which wanted to sell us DPA oil. And
like seal oil?
Seal oil, right?
Yeah, right.
And that was, well, relatively rich. And I have to lie now, but I think it was around 15 to 20% DPA in there. And they claimed that the DPA was the natural storage form of EPA and DHA in mammals, right? I'm not sure if that's correct or not, but definitely what you just told me about the DPA levels in the US and Japan strikes me too. I mean, that's very, very, so DPA must have a very important role in our body.
Well, it's regulated.
Yeah.
Yeah. Yeah. Whether, taking it as a supplement is important or not, that we still have a long way to go to prove that really makes a difference, independent of giving EPA and DHA. I know there's a pharmaceutical product in development that's is it EPA and DPA only, or EP? Yeah, I think it is. No DHA, but it's all free fatty acids.
I know. So it's a competitor product to.
Yeah, indeed.
I guess.
these right. So we'll see. I mean, we got a lot to learn. Next generations have plenty of questions to address in the omega-3 field.
That's, then it might be, if it's really the case, what you saw, that the DPA level is the same in the US than in Japan, then this indicates that there might be an upper level for DPA, right? Because in Japan, definitely they would have had much more source for building a higher volume of DPA, right?
Yeah, right, exactly.
Very interesting. Wow.
So, I think we need to study that more.
And how much, so from your personal point of view, how much EPA, DPA, and DHA should you ingest every day? Is there?
Well, we know, I think we published a paper last year looking at if you want to go from an omega-3 index of 4%, for example, which we think is low, of course, to 8%. We pooled data from about 10 or 12 different studies, or supplementation studies. And we looked at roughly how much it took to go from 4% to 8% using the statistical modeling. Okay. And it took about roughly 1,500 milligrams to go from 4 to 8. And that was as a triglyceride oil. If it was an ethyl ester, you needed some more in those studies, presumably because of not quite as good an absorption.
Right.
But I'm not saying that's everybody needs to eat 1,500 milligrams a day. I would think in the neighborhood of 1,000 milligrams a day would be for years, decades. That would be much better. That's sort of the Japanese intake, 900 to 1,000 milligrams a day. Yeah. At least the traditional Japanese.
Right.
Not the Japanese kids today, but you know what I mean.
Yeah. So you just mentioned TG, ethyl esters, free fatty acids. So there is a difference in the bioavailability of these forms, right?
Yeah, there certainly appears to be, and it's to me, it's mostly driven by whether you take your omega-3s with meals, with food or not.
Right, right.
You take them on an empty stomach, triglycerides are absorbed much better than ethyl esters, and phospholipids are absorbed better. If you take it with a good meal with some fat in it, that difference is not nearly as much.
Well, it's amazing really that the pharma industry has stuck all its development so far in the ethyl ester, right? Well, it's not true. It's not true, because the study we just talked about of the new development, it's a free fatty acid.
Right.
Which is also probably a good form, right?
Well, probably strength, it was a little disconcerting. So nobody quite knows what happened in strength.
Yeah, yeah. Okay, so with bioavailability, I think, probably the triglyceride form, the TG form, as you said, is better if you're in the fasting state, if you take them on empty stomach.
Right.
Ethyl ester form, well, it has to be bioavailable, because otherwise also the clinical studies like reduce and so on wouldn't have shown these results. So,
right, totally. I mean, it's absorbed. I mean, it may be absorbed more slowly, it may distribute differently, but it certainly has its effects.
Right. Now, coming to one of my last questions is, if you look at the lifespan of a person, you know, from a baby to a senior, is there a certain stage where you need more EPA and DHA in your life? Or would you say, look, a part of the fact that the mother needs to have a good DHA supplementation all the way through your life, you should take the same quantity?
That's hard to say with data. I think just if we just talk about impressions and, you know, what's my best guess is you do best by having a good supply, 500 to 1,000 milligrams of EPA and DHA from birth throughout life. I mean, I think that would be optimal.
Yeah.
And of course you need it, you know, -9 to 0 as well.
Right.
So
Yeah.
I don't know that there is a time. We're talking about really preventing disease, prolonging life. I think it's best. It's hard to get teenagers to take things like this. Hard to get children to eat
Yes.
omega-3 foods. But if I could snap my fingers, that's what I would have happen. That everybody would have enough omega-3 their whole life.
Yes. Yes. Okay. Okay. So maybe the last question, you told me that you also are working now, you established the Fatty Acid Research Institute, FARI.
Yeah.
What are you actually doing? What is your main focus in that institute?
Well, what our main focus is to use pretty much existing databases where fatty acid data is kind of like this study we published yesterday on total mortality, where fatty acids are available, have been measured by researchers, and the data is there, and then they followed people over time for different outcomes. Whether it be national surveys or professional, or, you know, groups like the Framingham study or the MESA or things like that, EPIC. And we want to look at, we would really just want to add as much literature we can on the questions of omega-3's relationship with health. Whether it's, and we did a study on COVID, we're going to be doing more studies on COVID, and even our first very small pilot study showed a potential benefit in reducing risk for death with COVID and having a higher omega, not giving omega-3 to COVID patients,
Right.
having a high omega-3, having a higher omega-3 people they survive better. And I think, so our goal really is to primarily focus on omega-3 and health outcomes. But we'll look at other fatty acids too. We're not just the omega-3 Fatty Acid Research Institute. So we're interested in the information the health information one can get from fatty acid levels in the body.
Right, right.
I think there's a lot of information buried there.
It's amazing how nature developed this, this very complex area, and all these multiple effects that these fatty acids have in our body. I mean, it's stunning. I think it really is.
Yeah, it's stunning. It's I think it's strange credulity to think this just happens by chance.
Yeah, yeah. In a way, it is, right? Okay, well, Bill, our time is up. I thank you so much for joining us. It's been very, very interesting.
Well, thank you.
And, thanks again, and I hope to speak soon again with you.
Anytime. Great chatting with you. Take care.
Okay, thank you. All right, so we got that. I think it's really very, very interesting what you're doing, Bill. It's amazing. I keep on, I don't know what to say there, but basically, as you just mentioned, sometimes it's hard to understand that our body has just been formed in a way, by coincidence, because it's so well tuned, everything. And
it's so finely tuned.
It's hard. The more you dig into it, the more complicated it gets, and the more fascinating, actually. Right?
More fascinating. Right. I was just looking at some studies recently of this thing called the red blood cell distribution width. It's called the RDW, and it's a very routine metric that anytime you have a complete blood scan done, red blood cells, white blood cells, platelets, they calculate this red cell distribution width, and it's really the coefficient of variation of red blood cell size.
Okay.
If you have a high coefficient of variation of red blood cell size, you have a wide distribution of cell sizes, from little red cells to big red cells. And if you have a narrow distribution, they're all about the same size. And it turns out that this red cell distribution width is a predictor of risk for heart attacks, strokes, death, I'm not sure, dementia, bad outcomes after surgery, even some bronchopulmonary dysplasia in premature infants. It's an amazing metric. And what fascinates me is that the omega-3s are in the red cell.
Yes.
And I've never thought about how the omega-3s might affect actual red cell biology, independent of this being a convenient cell that we measure omega-3s in. But actually it might, some of the benefits of omega-3 may be by changing the behavior of red blood cells.
Well, that's also very
They may be able to pick up oxygen or deliver oxygen faster, or remove CO2 better, or God knows what, but I'm just now fascinated to see, contact people who are doing research in red blood cell fundamental biology and say, give your red cells some omega-3 and tell me what it does to them.
Wow. Yeah, that's really very, very interesting.
It's really cool. So anyway,
but there's just one more thing, as you just mentioned that. Have you had any experience with omega-3 index and dementia? Is there correlation?
Yeah, we've done that in one study at least. We found people with women with a lower omega-3 were more likely to have developed dementia.
Really?
And
it makes sense, right? It's kind of logic, but
Yeah. There's evidence for that. It's quite a growing field. It's not as well developed as cardiovascular field.
Okay. All right.
It's coming.
Okay. Well, Bill, I won't hold you up any longer. Again, thank you so much. It was very, very kind of you to participate.
Oh yeah, great to meet you and get to know you. I hope we do this again.
All right. Okay. Well, stay safe. All right.
Thank you. Bye-bye.
Bye.